Hello dear all. So this is the question of linear algebra from the recent CSIR NET exam, June 2026. We will be solving this. I will be letting you know the way to solve this kind of questions quickly in the exam. Okay, before I proceed, let me tell you about the Aing Mathematics. Okay, so if you are preparing for higher mathematics, any exam, CSIR NET GATE, PhD interview, or NBHM or anything, okay, so you can join our courses and learn directly from me, and you can also join our membership to watch the complete playlist of the solutions of YouTube. Okay, so let us start. So, and the new courses are going to be start in this August, so you can contact. So let T, so what question says T r cube to r cube be a linear transformation such that T is not 0, T square is not 0. Okay, so see, but T cube is 0. Here you have to think that T is nilpotent. All the properties of the nilpotent operator should be in your mind, that its all of eigenvalue will be 0. Okay, so since T cube is 0, it means that T cube is not invertible. So T cannot be invertible. Okay, so the first option is there. So you will be solving this in a blink of an eye. If T123 is 013 and T212 is 023, see, first of all, observe that these are two linearly independent vectors. 123 and 212 are not scalar multiple of each other, right? Right, because you can observe it very quickly, because if you want to get 2 here, you have to multiply by 2. But here, if you want to 1, then you have to multiply by 1 by 2. So it means they cannot be scalar multiple of each other. So they are linearly independent. And also observe that 013 and 023 are also linearly independent. You can see it quickly, because if you want to get 2 here, you have to multiply 1 by 2. But by multiplying 2, you cannot get 3, right? So if you multiply 3 by 2, then you cannot get 3. You will get 6, right? So this is also not, these are not also scalar multiple. So what does it tells you? That there are two linearly independent vectors in the range. So observe this. There are two linearly independent vectors in the range. So I don't think that the linear independency of it needed. So they will be automatically linearly independent, obviously. So because these are, if the images are linearly independent, these cannot be dependent. Okay. So then which of the following statements is R2? T is not invertible. Yes, very obvious, because T cube is 0. Okay, implies determinant T is 0, right? So this is obvious. Rank T is 2. See, here you have to think quickly. T is not invertible. It means the rank of T cannot be 3. But there are two linearly independent vectors in the range. So what should be the rank? Rank must be 2. It means the rank at least 2. And rank cannot exceed 2 because T is not invertible. It means rank T must be 2. These two options are very easy to think. Okay, and how you will solve this, I will tell you. But what about the rank T square? See, rank of T is 2. Rank of T square may not be 2 or may be 2. So first of all, let us try to find the, so see, if you want to know the rank of T, then you can find any similar matrix to it, right? So let us try to find the Jordan canonical form of T. The Jordan canonical form of T, and we can know the rank of T and its powers from the Jordan canonical form easily. So J will be, the characteristic polynomial is x cube and the minimal polynomial is also x cube. So the Jordan canonical form is going to be this, right? Everyone knows to write the Jordan canonical form. So what is J square? J square, calculate it, you will get, it's very easy to calculate. So 0 1 0 0 0 0 1 0 0 0 0 0. Is this correct? Is this correct or not? Let me know if all the calculations are correct. So J is similar to T. J square will be similar to T square. So T square and J square will have same rank. So rank of T square cannot be 2. Okay, so it is absolutely wrong option. So it's very easy to solve this kind of questions. No need to think I mean, बहुत heavy सोचने की कुछ कोशिश नहीं है. This is very easy, and everyone knows that how to solve this kind of uh, options, right? You want to find the uh, image of 301. So you have given the image of these two vectors. So try to write 301 as a linear combination of these two. Suppose that. So if that doesn't work, then there may be other way. Okay. So first you have to try this. B212, and this is your work. Okay. So apply T and get that what alpha, beta plus gamma comes out to be. So will you all be doing this? These are merely calculations, so you will do this. So let me know this is correct or not. Anyone solved it or not? Let me know. So this is correct or not? This is just a calculation. Yeah, Kinjal, let me know.
Yes,
It
it
is
is
it
correct.
correct? Okay, so it is correct. You all will be doing this, so this is not difficult. So now let me know. Let's see. When how many of you could not solve this in the exam? Could you raise your hand? And now you realize that this is very easy to handle in the exam, at least. So did you find it difficult to solve in the exam? There are many. Okay. So what you were missing? So now try to see what you were missing. So try to, utilize all the information which is given to you. It is given that T is a nilpotent operator, so it cannot be invertible, right? The first option is very clear. So we want to know about the rank. So rank cannot be 3 because T is not invertible. So what rank can be? It can be 1, 2 because T is a non-zero operator. And you have to realize it quickly that these are linearly independent. So rank must be 2. Once you solve these two, then for 3, you can just pick an example and you know. But when you pick some example, so try to see this. When you pick some example, then that example must, satisfy this. Okay. Otherwise, फिर कैसे करो? Just pick the Jordan canonical form. Because to know the rank of T, you can use any similar matrix to T, right? And Jordan canonical form is similar to T, and it's easy to determine the Jordan canonical form. You have to be able to think quickly. ऐसे करना होगा आपको. Okay. Okay. So, and to find the notes of these, and I mean latex notes of these, digital notes of these questions. I mean detailed notes. Try to detailed notes. See the description. Okay. See the description of this course. You will find that there. Okay. So any questions?